Hello there, fellow mathematicians. In this video, I want to go over 30, 60, 90 triangles and where the shortcuts actually come from. So, across your studies, you've probably come across a chart or something along those lines where you have a 30, 60, 90 triangle. It looks probably something like this. And then on the chart, you essentially always know that the hypotenuse is going to be 2x, and then the side length across from the 60-degree angle is going to be x times the square root of 3. And then the side length across from the 30-degree angle will be just x by itself. And whenever I see something like this, I like to know where it comes from because that's what helps me figure out how this actually works. So that's what I'm going to do in this video. So let me get this triangle out of the way real quickly, and let's start looking at this one. So, right off the bat, the first thing that I'm going to do is I am going to essentially take this triangle and I'm going to copy it so it's the exact same triangle, and then I'm going to set them right next to each other like this. So I've essentially put their sides next to each other. So uh, this is all one line, this is all one line, and then essentially I just kind of created a new triangle. And that means that this is going to be another 30-degree angle. This is going to be another 60-degree angle. And this is also going to be another right angle. So, if you look, what I have just done here is I have created an equilateral triangle. So, what we know about equilateral triangles is that if this is an equilateral triangle, the angles here are all going to be the same. And then that also means that the side lengths are also all going to be the same. And since we know that all three of these angles are the same, we can say, okay, this is going to be an equilateral triangle. So now we can start figuring out where the shortcut actually comes from. So first things first, I am going to look at this side length, and I'm going to say this is C. It doesn't really matter what you choose for that, but just for the sake of this video, I'm going to use C. And that'll come back later. I'll talk about that later. Now, like I said before, when you have the 30, 60, 90 triangle, if this is the 30, this is the 60, the angle, the side length across from the 30-degree angle is going to be x, right? So I'm going to put everything here in terms of x. So I'm going to say, okay, this is going to be x. And then, of course, this also has to be x because these are this would be the same length as this. So if you think about it, what would be the length of this entire side? Well, it would be x plus x. So this will just end up being 2x. And since this is an equilateral triangle, they all have the same side lengths. So then this is also going to be 2x. This is also going to be 2x. So if you think, well, we already have two of the values from the cheat sheet chart. We have the hypotenuse value, and then we have this value. Now we just want to find this value right here, and that's where you get the ugly square root of 3. But anyway, let's get right to it. So I'm going to use Pythagorean theorem here because this is a right triangle. So Pythagorean theorem is a squared plus b squared, the two legs squared, is going to be equal to the hypotenuse squared. So we have our hypotenuse here. This is going to be 2x. So we're going to take 2x squared is going to be equal to x squared plus c squared. Okay, swell. Now, I've made this mistake before. Like when I've been doing quick math like this, I would say, okay, 2 squared, I'll say, okay, this is going to be 2x squared. But you have to remember that when you have the exponent on the outside, it's really going to be 2x times 2x. So this will end up being 4x squared is going to be equal to x squared plus c squared. So now I'm going to subtract x squared on both sides. So then we're going to have, so this will cancel out. And then we're going to have 3x squared is going to be equal to c squared. All right, so let's get this 3 out of the way. I kind of want this to be on this side. So I'm going to divide both sides by 3. That'll cancel that out. Then we have x squared is equal to c squared divided by 3. Now I kind of want to get rid of this exponent over here, so I'm going to square root both sides. So this is essentially the same thing as just square rooting the oh, hang on. So this is essentially the same thing as this square rooting the numerator and the denominator. So it's going to end up looking like this. So that means, sorry, this is kind of going around the screen a little bit. I'm running out of room. So this is going to be the square root of x squared is just x is equal to the square root of c squared is just going to be c over the square root of 3. So I want to get c by itself now. So I'm going to multiply both sides by this square root of 3. So then we get x times the square root of 3 is equal to c. So now we've defined c in terms of x. So what I can do is let me get the c out of the way, and then I can write x times the square root of 3. So there you go. If you just look at this one triangle over here, that is essentially where the 30, 60, 90 comes from. So because we have the 60-degree angle, the side length opposite of the 60-degree angle is going to be this x times the square root of 3 value, and then the side length value opposite of the 30-degree angle is going to be x, and then the hypotenuse is going to be 2x. So anyway, I hope this was helpful. If you want to look at any more resources, I bet that you can practice on Khan Academy or even uh, put this into practice yourself. It's always great to watch somebody prove something and then you do it just so it stays in your mind or something along those lines. Well, anyway, thanks for spending some time with me, and I wish you luck on your future endeavors. See you later.